All right, so thanks again for joining the meeting. So the end goal of this is to help OVN developers to learn about DDlog and eventually to help them start maintaining the DDlog version of ovn-northd. We're probably not going to get there today, but at least we can start sort of talking about the ecosystem. And there are a bunch of people who are responsible for all this. So in addition to myself, Leonid, Mihai Budio is helping to develop and maintain DDlog. Justin Petit helped write the DDlog version of northd, in particular the C part of it. And Ben was crazy enough to sanction all this and has been extremely supportive of the effort all the way. Okay, so let me start with some high-level questions. Oh, by the way, please interrupt me with questions anytime during this. And I think it'll probably go for 40 minutes to an hour. I'm not quite sure. Okay, so some high-level things. So why the hell are we doing this? What's going on here? So we are rewriting parts of OVN in this new language called DDlog, which sounds pretty crazy. So the reason for this is that currently the way DDlog and the way OVN and in particular northd works is whenever anything changes in the northbound database, it goes and pretty much recomputes the entire southbound database, which is one of the reasons why it's relatively simple, but it's also one of the reasons why it's not easy to scale OVN to very large networks, because recomputing configuration of a large network on every change is getting expensive. Now, of course, it's in principle possible to take the C code and make it more incremental. But this kind of incremental computation is fairly tricky. It adds a lot of complexity. In my experience from various other projects, when you take this kind of non-incremental code that's designed to compute updates, to compute the entire output in one go, and you try to make it incremental, you increase the amount of code by an order of magnitude. And DDlog is this language which is designed to exactly solve this problem. With DDlog, you basically write your program as if it was non-incremental. You just describe your computation as a one-shot computation, and then it makes it incremental fully automatically. Now, you might be wondering why not use some other language. If C is maybe not a good option, maybe there is some other well-established language we could use, and the answer is I don't think there is one. So the reason we developed DDlog in the first place is that this is a fairly common problem, doing incremental computation, and I don't think there is any other language out there that quite solves it. Okay, so what exactly are we rewriting in DDlog? Well, at the moment, just the northd. The long-term plan is possibly also look at the OVN controller in the future, which is apparently an even bigger bottleneck. So right now, Han has been doing a lot of work to make the C implementation more efficient when doing incremental computation. Maybe that's the way to go. Another option is to, if the northd experiment is successful, we might do the same with the controller in the future. Okay, so what is DDlog? Like, let's start trying to understand what it is. So there are two ways to describe it. One way is you could say that it's a data flow language. So one way to sort of visualize what DDlog is doing, a DDlog program has a bunch of outputs, which are tables. Like you can think of them as database tables, and it outputs another set of tables. But the way it does it is it takes a stream of updates to input tables as input. So for example, on every iteration, some input records are added or removed or modified, and it takes this update and it generates an update to the output tables. And then the next update arrives and so on. And on every step of the process, it's incremental. It only makes changes to the records affected by the update, and usually it does only a tiny fraction of the work it would take to recompute the whole output. And internally, this program is also a data flow. It has some intermediate relations, and it flows data between them. And we'll look a little bit more into it in the rest of this tutorial. Another way to describe it is more sort of syntax-focused, is it's a rule-based language. So the problem is you cannot easily take a language like C, like a general-purpose language, and make it incremental. It's way too hard, so you have to somehow restrict the model of computation. You have to restrict what you can write in the language. So DDlog is inspired by Datalog, if you're familiar with this language, but also if you're familiar with Datalog, don't worry. DDlog is actually way more powerful, so you can do a lot of things, and you can do things much more nicely than in Datalog. So here's an example rule that one might write in DDlog. So don't worry about the details too much for the time being. Let's just look at the high-level structure. So this rule computes an output table, which in this case is out DNS, based on a bunch of input tables. And the rule consists of two parts. So the part on the left of the rule, everything before this semicolon dash symbol, is the head of the rule. This is the output of the rule. And then the rest, all these clauses that follow the colon dash, is the body of the rule. So in the body of the rule, we basically compute an assignment to a bunch of variables, and then these variables form a tuple that we write to the output table. So in this case, for example, I'm just going to go through it quickly. Don't worry about the details too much for now. So we select all the records from the nb.dns table, and as you might guess, this is the DNS table in the northbound database. So we're going to bind every record to this nb.dns variable. We are then going to look at another table. So it's an intermediate table computed elsewhere called logical switch DNS. And we're going to select a record from this table such that the second column is equal to the UUID field or UUID column of the DNS record. And now we're going to extract a logical switch UUID from that table. And you can think of it as a database join. We are then going to aggregate all these UUIDs for each NB-DNS record. And this aggregate is going to be a set, and we're going to call this set the data path variable. And then finally, we're going to compute another variable called IDs, which is obtained by taking nb-dns.external IDs, which is also a column of the DNS table, which happens to store a set, and we're going to add a new record to the set. So key is DNS ID, and the value is the UUID. And then we're going to take these various variables that we computed, and we're going to write them as a tuple in the out DNS table. Okay, so what should you expect as you start working with DDlog? Well, I'll be honest with you, it's probably going to be a little bit of a rough ride initially. Well, because first of all, you are learning a new language, which is never completely easy, and this language is quite different from C. It's quite different from what OVN is implemented in at the moment, and it's also a new language in that we just developed it in the last couple of years, so it will have some rough edges, the language itself. In particular, you might run into some usability issues. Maybe the compiler message is not particularly meaningful. Maybe some behavior of some feature is not what you expect. Maybe you find that implementing some particular behavior is way too complicated. If you run into any of those, please complain. There are definitely performance issues because even though DDlog is designed for very fast incremental performance, this OVN program that we wrote is an extremely complicated one, as far as this type of declarative languages go. And even though DDlog is very fast on many other use cases, there will be situations where there will be some cases where we will have performance problems in OVN. We are fairly confident we know where they will come up. We know we can fix them, or at least we think we know. It's going to be difficult to fix them before we actually run some scale tests. So if you start seeing poor performance, please report it, but don't worry too much. We think we can take care of it. Okay, there is one problem that's actually really annoying, and it may not go away in the near future, even though we're looking into it, and that's compilation time issue. So the way DDlog works is it compiles the input program into Rust, and then it runs the Rust compiler. And the Rust compiler on this particular auto-generated program is really slow. Like at the moment, on my laptop, it actually takes 10 minutes to compile the northd. Which is not great, and that's just one pain point that we have to live with. There are also not too many tools available for DDlog right now. There is no IDE, there is no cscope for DDlog, so browsing the source is a manual process. So having said that, if you run into any issue at all, ranging from poor documentation to bugs, you can file an issue on GitHub or just email me, and we'll try to take care of it as quickly as possible. At the same time, I think there are also lots of nice properties of DDlog that I hope you will come to enjoy. For one thing, it's a safe language. So you should not be able to write a program that has a buffer overflow or null pointer dereference or use after free or any of those C problems. It has a nice type system that's way more powerful than C in many ways. And if you're familiar with languages like ML or Haskell or Camel or even Rust, like any of the modern languages, you will probably appreciate those immediately. So let me show you an example, because it will actually come up a lot in the northd code. So DDlog has these variant types, which are a little bit like C unions, in that it's a type that can be one of several different things. But they're, unlike C unions, they're actually completely type safe. Okay, so here's one example. Here we declare, this is example from the standard library. So this particular type will occur a lot through any DDlog program. So it's an option type, which represents the fact that some value is optional. So in the C world, it would be a value that can be null, except this is a safe version of that. So it has two variants. The first variant is sum. It just says that the value exists. And the second variant is none, which means that there is no value. It also has this type parameter called tic_a. So it's just a placeholder for a concrete type. So it's a polymorphic type, and you can substitute a with absolutely any other DDlog type. So you can apply this to any type. Okay, and here's an example of a function that returns this type. So set nth extracts the nth element of a set. So it takes a set of some type. So it's another parameterized type and an index n. And then if a value with this index exists, it will return this value. Otherwise, it will return none. Okay, so now you can see, we can look at how we actually use this function in the program. Okay, so here's a small fragment where we have a set called acl.severity, whatever that is. We extract 0th element of it. Okay, now if the set is empty, we're going to get none, otherwise we're going to get some. And unlike in C, there is no way in DDlog to ignore this. There is no way to pretend that you always get some. So instead, you have to take this value and you have to match it, and you have to, inside this match construct, you have to have a clause for every possible outcome, which can be either none or some. And then if it's none, then you use some default value. Otherwise, you use you bind the severity variable to the content of the value returned by the function, and then you can use it on the right-hand side of this match statement. Okay, so another thing you see in the same example is string interpolation syntax. So this is another thing that DDlog actually makes very easy for you to build strings out of various things. So in this case, so this severity is a variable which is probably of type, it's probably some kind of integer type. And we want to form a string which says severity is equal to this integer value. So all you do is you put the $sign and curly braces, and you put an arbitrary expression in between the curly braces, and DDlog will happily convert it into a string for you, and will concatenate it with the rest of the string. Any questions so far? Okay. And then another nice feature of DDlog is, especially as we get into performance tuning, it has some built-in tools that help profile memory and CPU usage, and it also helps debug what's going on inside DDlog. And we are working on to improve those tools. Okay, so how do you actually learn about DDlog? Well, there is no way around this tutorial document. It's probably the best source of documentation we have at the moment. That this is the one that we are going to try and maintain as much as possible. So I would say that the first step is go to this tutorial and read through it and probably try some of the examples. There are also a few, well, there are a bunch of examples of DDlog programs in the Datalog tests directory. The best one is, again, tutorial.dl, which is all the examples from the tutorial, because these were specifically designed to sort of introduce DDlog features one by one. So that's probably the best one to look at, but there are also a bunch of other examples in the same directory, which are all way simpler than the OVN program itself. Okay, so the first thing you'll have to do as you start working with DDlog is you're going to have to install it. And you can install it either from source or use a binary release. So for now, for OVN development, I would recommend going from source, just because we're still making changes frequently, and not all these changes immediately get released. Most frequently, we just add some functions to the standard library. So DDlog itself is written in Haskell, so if you need to install it from source, you have to install Haskell first. Fortunately, it's just a matter of executing just this one command, which will install the Haskell compiler stack for you. Because DDlog outputs Rust, and you have to compile Rust, you also have to install Rust, and that's another command line. Please don't miss this note, which basically says you have to make sure that the path to Rust tools is in your path variable. Okay, and then finally you just get DDlog from Git, and you run stack build and stack install, or just stack install, which is basically Haskell's way to compile and install the program. And yeah, like I said, there are also binary releases, and the plan is to eventually OVN developers will just have to use those. But for now, let's stick to source releases. All right. So now we know how to install DDlog. The next step is to install, compile and run the DDlog version of northd. So this is currently being maintained in Justin's private branch of the OVS repository. The branch is called DDlog. We are going to move it. I think the plan is to move it into the main OVS repo soonish. We just have to. There are a couple of wrinkles with test cases, but hopefully we'll move in the next few days. Okay, so you need to check out this branch. You also have to configure OVS with this new DDlog flag. And this path that follows it is the path to the lib directory inside the differential Datalog repository. So this is where all the DDlog standard libraries are. Now, if you compiled OVS in this way, then there's still one more step you have to do in order to actually run the DDlog version of northd. So the nice thing here is we now have both implementations, the C and the DDlog. So you can easily switch between them. You just need to uncomment the right line in this ovn-northd file. So if you uncomment ovn-northd DDlog, then you will magically be running the DDlog version of northd. Okay, so let me explain how the new build process works for northd. So you can see the details in the automake file, but let me just quickly walk through it so you understand what's going on there. So the goal of this whole process is to take a bunch of DDlog files and build a northd executable out of them. So we start with the existing OVSDB schema files for southbound and northbound databases. So the thing is, like I said, DDlog takes tables as inputs and produces tables as outputs. And in case of northd, these tables are actually OVSDB tables. And so we developed some plumbing to automatically interface OVSDB with DDlog. So there is a completely automatic way to make those OVSDB tables to look like DDlog tables to the DDlog program. And so to do this, we first run this tool that's part of DDlog. It gets installed with DDlog, called OVSDB to DDlog, that will take the schema files and will produce DDlog files that contain the declarations for all the OVSDB tables, as well as some plumbing that for now doesn't matter. And then we combine these two auto-generated files with a bunch of sources, DDlog sources, that actually implement the northd logic. That's what Justin and myself developed in the last few months. So we take all these files, all these DDlog files, and we run the DDlog compiler on them. And the DDlog compiler produces a Rust project that has a bunch of Rust files that you hopefully should never have to look at. But it also generated the DDlog.h, which is a header file used to invoke the DDlog API from the C program. So we take this Rust project and we run cargo, which is the Rust compiler toolchain, the Rust build system, and it outputs a normal static library that can now be linked against a C program. Okay, and so the final step, we take this library, the lib-ovn-northd DDlog.a, and we link it against the C program that Justin developed, which is basically the main control loop of the northd. So all it does is it subscribes to updates from southbound and northbound databases, and when any of those updates arrives, it takes this OVSDB JSON and pushes it to DDlog, and then it extracts another bunch of JSON from DDlog, which turns into OVSDB table updates. So it's basically a relatively thin wrapper that simply calls DDlog. And you compile this as usual with GCC, and finally you get an executable which is called ovn-northd -DDlog. And this is what runs instead of the normal ovn-northd. So do you guys have any questions so far?
Yeah, so one question, does this, so when it's translated into, I mean, this datalog.a library itself, does it talk to OVSDB, or it's just everything to OVSDB is only from the C program, the main loop?
Right. So this library, it doesn't directly talk to OVSDB, but it takes JSON. It takes OVSDB JSON as input, and it produces OVSDB JSON as output. So the actual OVSDB communication happens in the C program that Justin wrote. Okay, but this program, it essentially doesn't even have to parse JSON. I think it does at the moment, but that's a technicality. So really all it does is it subscribes to updates from OVSDB, and then it takes the update as one big chunk of JSON and just gives it to DDlog and tells this is an update to input tables. And then it extracts from DDlog another piece of JSON, which it just needs to send to OVSDB as an update to both northbound and southbound as an update to its tables. Make sense?
Yeah, thank you.
So ovn-northd, yeah. So the ovn-northd DDlog-C doesn't use the ideal, right? It just uses the JSON RPC of.
Right. Yes, that's correct. I understand that in writing it, Justin, I think, copy-pasted some code from IDL. So he's probably the one who can comment more on this. But yeah, it doesn't use the IDL layer.
Okay.
All right, so this is the last high-level slide, and then we're going to actually look at some DDlog code. So this just illustrates the interaction at runtime. So the northd is triggered by a change to either northbound or southbound. So let's just look at the northbound as an example. So it gets a bunch of JSON that represents a change to some of the records in the northbound database. So this delta is given to DDlog, which computes to other deltas, also in the JSON format, and these two other deltas represent changes to the northbound and southbound that have to happen in response. One of them or both of them can be empty if there is nothing to do. Okay, then the next thing that happens is DDlog, or northd rather, actually waits for northbound and southbound to acknowledge those changes. And to basically send their new state back to DDlog. So if nothing else happened in the system and all changes were applied successfully, then at this point DDlog will say, I have no other deltas, meaning that both northbound and southbound databases are exactly in the state they have to be, given the current configuration. But if maybe something else happened in the meanwhile, maybe the user typed another nbcatl command and added another logical switch or whatever, then this whole thing will repeat itself again, and DDlog will produce another delta. All right. So, like I said, really to learn DDlog. Sorry, go ahead.
Just one question. Like, suppose if the southbound, the ovn-northd DDlog loses the connection to the southbound DB server. What happens if any changes happen to the DB? On the north DB, and then again when it reconnects, what happens?
Right. So actually, I'm not completely sure what Justin Scott does right now, but the answer really is when anything goes wrong, the simplest recovery you can do is you can just kill DDlog, kill northd, and restart it again, and feed it the entire current content of northbound and southbound. And it will again produce the correct delta. It will just take a little bit longer. So it's stateless in the sense that at any point in time, all it needs to know is what's currently inside the NB and SB databases. Now, you could be a little bit more clever, and let's say if you just lose connection to one database, well, you don't really have to kill northd. You can just restore the connection and either dump the entire database to DDlog, or if you have a way to determine what's changed, just dump the change. Does this make sense?
Yes. Yeah.
Sorry.
Right. So basically, as long as you have sorry, go ahead.
Yeah. So how to dump the change to Datalog directly without? I mean, is that a manual process, or is there any tool to do that?
No, it should all be completely automatic. So basically, when you kill northd and restart it, then the first thing it will do is actually I should be a bit careful because I would have to ask Justin exactly what happens. Okay, so let me put it this way.
If you kill northd, I understand it will recompute, right? You will restart and get all the data and recompute. But
right.
You say if you don't kill northd, there's some way to do it?
Yeah, it still has to be fully automatic. So there is a command to clear. The first thing you would do is you would tell DDlog to clear all the southbound tables, and then you just read the entire southbound DB, and just you probably get one huge piece of JSON or whatever you do, and just feed them to DDlog. So I'm not sure. I don't think this particular functionality has been implemented, but that's how it would work.
Okay, basically the C code should be able to handle this, right? So if we add some code in. Okay.
Right.
Thanks.
Right, and it shouldn't be hard to handle. Like all you do is you detect that you lost connection, and then you make a few calls to DDlog to clean the tables and to reinitialize them.
Sure. Thanks.
Okay. For better or worse, the way to learn this is to read the manual and ask me to improve it if something is missing. But let's look at some code snippets to start giving you a bit of a flavor. Okay, so I'm gonna switch to Vim at this point. Okay, so the first thing you're going to look at is we're going to look at, let's see, which one did I want to show? Logical switch. Sorry.
So Leonid?
Okay. Yep.
So this is Justin. So I was looking at the code. I'd forgotten some of the specifics. I think what will happen is if there is a disconnection, we'll restart the finite state machine in northd DDlog, and so we'll just restart. But I'm not quite sure. It's probably something we should discuss more. I'm not sure if that will work properly with the DDlog code, or if we need to send something to indicate that. So it'll send basically a whole new set of changes.
Right.
And so I'm not sure if DDlog will handle that properly, or if we need to send some sort of indication that we're starting over.
Right. Okay. Thanks for clarifying. Yeah. Let's talk about it maybe offline. But
yeah.
So basically, if you're in the state where you don't know what the hell happened to southbound database, like it might be in a completely new state that you didn't expect because you got disconnected, then the right thing to do is to clear all the southbound tables first. There is an API for that, and then just feed the entire database. Yeah, unless you think that it hasn't changed, in which case you don't need to do anything.
Okay. Yeah. I'll make a note. We should when we go through and get the code ready for public consumption, we can make sure we handle that use case, or that not use case, but that situation.
Right. Okay. Thank you.
All right. Thanks.
Okay, so the first thing we're looking at is this auto-generated file called ovn-northbound. So as you might imagine, it's the DDlog representation of OVSDB tables from the northbound database. So we're looking at the logical switch table, and it has basically exactly the same field that the OVSDB table has. And you can start seeing some of the DDlog types. So your UID is just a user-defined type for a 128-bit integer. The name is a string. So for all the columns whose multiplicity is not exactly 1, we use the set type, which is one of DDlog's standard library types. So for example, the ports column is a set of UIDs, which are foreign keys in this case. There are also maps. So we use maps for well, basically wherever you would use maps in OVSDB, yeah, for example, for external IDs. Okay, so the reason I showed this particular table is that next I want to show some rules that use this table. Okay, so what exactly do I want to show? Logical switch ACL.
So sorry to just quick question about this. Is this definition auto-generated, or is that manually coded?
Yes, so that the code you just saw is auto-generated.
Okay, thank you.
So basically, yeah. So basically, what happens is so there is this tool that takes OVSDB schemas for SB and SB and translates them into the DDlog format. Excuse me. Okay, so most of this northd implementation that we wrote, basically what it does is it takes all the input tables from OVSDB and computes a bunch of intermediate relations that give you some kind of convenient representation of these tables, and then finally generate the outputs. So here's one called logical switch ACL. So what it does is it contains tuples where every tuple is logical switch ID and ACL ID for some ACL that applies to this logical switch. And it turns out that there are two types of ACL that apply to a logical switch. First, there are ACLs that are listed in the ACLs column of the logical switch table itself. And second, for every port of the logical switch and for every port group that this port belongs to, there might be some ACLs defined for that port group, and we also want to include them here. Okay, so respectively, we have two DDlog rules to compute this intermediate relation, logical switch ACL. So the first one simply says, for every record in the logical switch table, so sorry, the NB prefix here, so DDlog has this module system, so when you import a DDlog module, you can give it, you can import it with some name. So NB here is the name we assign to the northbound tables. So we take the logical switch from the northbound table, we extract the UUID and the ACL columns from it, and then we apply this flat map operator. And what it does is it turns, in this case, ACL is a set, is going to turn every element of the set into a separate record, right? So that in the output relation, we don't just have sets of ACLs, we have a separate record for every ACL in the set. And so this flat map operator, it returns a bunch of records where every record is an individual ACL, and then this is what we write into the output table. So the next rule, I will actually go into more detail and we'll try to visualize it. So hopefully things will start being more clear. So the second rule, it also takes a logical switch, and then it takes every port of the switch, and then it takes the port group that this port belongs to. And it will extract every ACL from that port group. Okay, so first we'll go just syntactically through it, and then I'll try to explain what actually happens. Okay, so again, we take every record in the logical switch table, and we extract two fields. We only care about two fields here, the ls field and the ports field. And the ports field is the set of ports. So next we extract the flat map operator. So we apply the flat map operator to turn the set of ports into individual port IDs. And we bind the output of this operator to the port ID variable. So next we have this port in group relation, which is another intermediate relation that we computed somewhere, and it basically for each port specifies the group that this port belongs to. And so we're going to look at this relation, and we're going to find a group ID for this port ID, if one exists. So it's basically, you can think of it as an SQL join. Okay, so now we have a group ID, and we can use this group ID to look up the group in the port group table. So we use the group ID as UUID, and we get the list, the set of ACLs for this group. And then once again, we use flat map to convert the set of ACLs into individual records. Okay, so now we finally have our ls ID, the logical switch ID, from the first clause, and we have an ACL ID that we just computed. So we combine them together in a tuple and write this tuple in the logical switch ACL table. Okay, so let's go through this again, but this time visually. Okay, so the first line takes a record from the logical switch table. Okay, so this one. And specifically, it extracts two fields from it, the ls field and the ports field. So we are going, so what I'm showing you is the actual data flow that DDlog builds internally. And every operator of the data flow outputs a new relation. And in this case, it outputs relation with two columns, ls and ports, extracted from the logical switch table. So the next thing we do is we flat map it. So we turn a set into individual values, and we're going to bind the output to port ID. So the output of the flat map operator will be another table that still has the ls column, and instead of ports, it will have port ID, and it will have one of those for every port in the input set. Okay, the next thing we do is we look up this port in the port in group table. And this is basically a join. It's a join where we take the relation we computed so far and we join it using this port ID field with another relation. So here's a join operator that takes port and group. And what it outputs, so let's go back to the source code. So from this join, we get the group ID value. So the output of this join is another relation that still has ls and port ID fields, but now it also has group ID for every port. So next we join again. So now we look up the port group table using this group ID, and we extract the ACLs column from it. So we are going to join with the port group table, and we're going to get as output a relation that has all the same columns, but also the new ACLs column, which is a set of ACL IDs. And then finally, we do the flat map. And the flat map, again, takes every set of ACLs and expands it into individual values. So the output, there are two things that happen here. First of all, we replaced the set of ACLs with individual values. And second, because we don't care about port ID and group ID, because we don't use them in the output, we throw them away. And we just have logical switch ACL pairs. And this is exactly what we write into the output relation. Do you guys have questions about this? Okay, hope I didn't lose it.
Yeah, it was pretty clear. Thank you.
Excuse me, can you say again?
No, I mean, it was pretty clear. The diagram helped a lot in understanding.
Okay, fantastic. I'm glad it made sense. Okay, so let's
one question.
Yeah.
Could you go back to the code? There's two logic switch ACL. So firstly, you did just for the flat map ACLs, and then you have the same logic LS logical switch ACL. So is that a union of two tables?
Exactly.
To compute. Oh, okay. Okay.
Yeah. So in the output relation, you'll have the outputs of both these rules.
Okay, got it.
Okay, so yeah, thanks for keeping up, guys. Okay, so let's look at a couple more things. So the next thing we do is we take this relation we just computed, and now we want to compute a subset of it that only contains stateful ACLs. Probably there is some flow that we compute somewhere that only applies for stateful ACLs, and so I thought it would be convenient to have that relation ready. So this is kind of the form of modularity, one of the forms of modularity that you have in DDlog. These computations that occur multiple times, you can represent them as relations and compute them once. Okay, so we compute this logical switch stateful ACL relation. The rule is very simple. What it says is, let's take a record from logical switch ACL that we just computed. Now we want to determine if this ACL is stateful or not. But the ACL is just UUID, right? It doesn't have any information in itself, so we need to do a join with the ACL table using this UUID as a foreign key. And here we only want to consider those records from this table whose action is equal to allow related, because those are the stateful ACLs. Those happen to be the stateful ACLs. And so this is another sort of important DDlog feature, if you will, that lets you filter the relations by basically specifying either the exact value or the structure, as we'll see in some other examples of specific columns. So the result of this will be LS and ACL pairs, where ACL corresponds to allow related action in the ACL table. Any questions? Okay, and so the last thing we're going to do with ACLs today is we're going to compute yet another intermediate relation. So this relation is called logical switch has stateful ACL, And what we want to have in this relation is we want to have exactly one record for every logical switch. And this record will have a flag called has_stateful_ACL, which will be either true or false. And it will be true if there is at least one stateful ACL defined somewhere for this logical switch, and false otherwise. Okay. So again, there are two rules to compute this relation. The first rule says that if we have a logical switch stateful ACL record for ls, and we don't even care what the ACL exactly is, so we use this placeholder underscore for it. So we say if there is at least one record in the stateful ACL table for this ls, well, then we know it has at least one stateful ACL, and we write true for it. The second case is more interesting. We want to include all logical switches that do not have any stateful ACLs. Okay, so we say for every record in the logical switch table, such that there is no, so this is what this NOT stands for, there is no record in the logical switch stateful ACL table with this ls ID. So this corresponds to anti-join in the SQL world. Then for any such ls, we will write, we will create a record that's false. And then we can use this relation to build another relation. So this switch relation, it basically aggregates all the information that we ever care about for a particular logical switch in one place. And it has a bunch of fields. The first field is just the logical switch record extracted directly from the northbound database. And then there is name and a bunch of flags. And one of the flags is has_stateful ACL. And so the way we compute this flag is we join a record from logical switch with a record from logical switch has_stateful ACL table that we computed so far. And this is probably where I have lost everyone. So there is just one more example that I think I wanted to look at. Okay, so this is a particularly important example because after all that the northd is doing really is computing these logical flows that then go into switches. And most of the code, if you look at the main file for northd, which is called ovn_northd.dl, most of the code lines in this file actually compute various flows. This is where most of the logic is. So we're going to look at the most simple one, which is ingress table 1, table 0. Okay. So this shows slightly different syntax. So one thing that Ben realized a few years ago when he was actually playing around with similar ideas is a lot of the time it's more intuitive to write these rules as for loops. Even though it's not a real for loop, it doesn't it's this incremental rule-based thing. The natural way to express rules is usually you go like this: for every x, generate a flow, and x can be a switch port, a switch port IP address pair. So for every entity from some kind of relation, do something, generate a flow. And it's easy to write it as a for loop. So here we write this for loop that actually compiles into a rule. So it says for every record in the switch relation, we're going to create this simple static rule that I think catches the case for logical VLANs are not supported. We store those flows in the intermediate relation called flow, and we build it. So there is what the data path name, stage, priority. So the match condition in this case is a static string. In many other flows, you will see quite complicated logic computing those match conditions, and the action is also just drop. And again, in many other cases, it's pretty sophisticated logic to actually compute this, and external IDs is empty. Okay, so this is actually all I wanted to go through today. There's obviously much more to it, but I felt that it will be too much for just one, for just the first tutorial. So do you guys have any questions? Okay, good. So, like I said, probably the next thing to do if you're interested to continue is to look at the tutorial, but also start looking at the OVN DDlog code. I will keep working on. I will start writing some more documentation for this code so that it's easier for people to understand what's going on here, because it's a fairly complex program. Ideally, we should try and have another meeting with whoever is interested and see how we would add support for some of the new new OVN features that were added in the last few weeks as some kind of hackathon.
So, is there any point to for us to, if we encounter some problem, let's say the output is not expected, what's the typical way to debug?
Right. So there are a few techniques that I use. So let's see what the okay. So logically, what you want to do is you want to figure out which intermediate relation was not computed correctly, right? So what you really need is to dump the content of intermediate relations. And there is some debug code in the C program where you can dump the content of any intermediate table. Wait, is this true? Okay, yeah. At a high level, that's how it works. I should probably write some more detailed documentation. But basically, you should be able to dump any intermediate table. And so what you do is you add a bunch of those dumps that typically lead you to understand that maybe some record is missing, or there is a record that doesn't look like what you expected it to look. And that's how you debug it. Another mechanism that you might want to use in combination with this, it's a little bit tricky to debug DDlog sometimes, as part of this bigger ecosystem where there are all these other moving parts. So I added a feature recently where you can record the execution, record the entire execution of the northd as a command file, and you can then run this command file against DDlog as a standalone executable. And the nice thing there is you can easily dump any tables from there. You can easily modify some commands. You can easily see the state of anything at any point during the execution. So that's sort of a more as you go deeper into it. And then finally, actually maybe this is what I should have started with. Is the first thing I usually do is I compare the output of DDlog with the output of C, because it's so easy to switch between the two. So when I see a test case fail, I just run it twice with DDlog and with C. I just dump the content of northbound and southbound databases at various points in the execution, and I compare them. And that's usually a good starting point. This is where I see how the output of DDlog diverged from the output of the C version. So does it make sense in principle? I realize I didn't tell you exactly how to do any of these things, but
yeah, I think it's very helpful. Thank you.
So and it's a good question. So I guess the first thing I'll do after this is I will document this debugging process. Yeah, so you can try it for yourself. Other question?
I was curious. So from your experience, you were saying that you've had some difficulty keeping up with the changes that are happening upstream. But I think you'd indicated just because you're not necessarily familiar with what the changes are trying to accomplish. So for how difficult do you think, once people get comfortable with the DDlog syntax, will it be for people to sort of maintain both, or to stay current on it until we've decided one way or the other which way we're going long term?
Right. It is true that like when I try to catch up with these changes, I really spend most of the time trying to figure out what the hell is going on in the C code. Okay, so in my experience, it's probably slightly easier, at least for me, to write DDlog than the current non-incremental C code. I don't think it's going to be a lot of fun for anyone to maintain two versions. So we don't probably want this as a long-term solution, but as a short-term, it's basically twice the development effort for specifically the northd component. So you do your design once. All other components are shared. So there is some library functions you add into various C libraries. That's all shared, and we can call those from DDlog. But whatever you would write in northd.c, you basically have to write the same in DDlog, and it's roughly the same number of lines of code. A little bit less. Yeah.
Thanks.
I think probably we can stay with one version of code and make it like everything correct, and do all the testing, performance testing, scalability testing. So when we can decide, when we're happy with this, then we can do a one-time migration for the native code to DDlog, and then we don't have to maintain two copies. Is that reasonable?
I think it is a good plan. I mean, I think that even after we do all the performance testing, probably it makes sense to keep the C code around at least for a little bit. So there will probably still be a period when we maintain both. Another thing I want to say, like one reason why we might want to add some of the features to DDlog is sort of as an exercise for all of us to sort of learn to program in DDlog. So the easiest thing to do would be to add one of the features that are already in C. But yeah, otherwise it might be a little bit too much of a moving target. Okay, more questions?
In terms of like packaging, I mean, when you see the Debian or RPM stuff, there's nothing there, right? In terms of DDlog or
no, not really. So I'm not sure. I'm not sure there will be. So basically, DDlog is probably long term is probably just going to be a binary you download from the DDlog website.
Okay.
I mean, by all means, you guys are Red Hat, so you might want to maintain some packages.
Yeah, I mean, ultimately we got to do that, I guess. Maybe first in Fedora.
Right. But just to be clear, for OVN users, they don't need DDlog, right? They just get the executable, unless they want to build it themselves. Like right. they just get the northd executable. So none of this Haskell, Rust, none of that they will actually have to deal with.
Right. Yeah, but normally we do have like the source RPMs, with all the source code and all. Yeah.
Right.
Probably
right. Sure. Okay.
If no other questions, like and like I just tried out compiling and I was facing some issues. Maybe I will share you the log.
Absolutely.
But before that, yeah, if someone has any other questions, I just shared that paste thing in the chat.
Did you just send me a message in the chat?
Yeah, you are able to see that in the.
Well, in fact, everybody's going to be able to see.
Yeah. Actually, I can see that.
He sent it in the Zoom conversation thread.
Yep.
Oh.
Okay. Interesting.
I'm sure I'm missing something. It's Fedora 30.
Okay, okay, it might be, this is on Fedora. Okay, interesting. I'll have to investigate. Yeah. Also, like, it would be great if you could submit these things as issues on GitHub.
Okay.
Easier to keep track. I mean, by all means, whatever is more convenient for you. But I guess the ideal way is
yeah.
Okay, so I look into it, and other than this, so let's talk offline. Like, it would be great, Han, if you could get in touch and see if you can do skill testing.
Yeah, I'll try to. Yeah, I can try to play with it and first get it running, and then since we already have an environment, we can do just a regression, but see how the scalability is.
Right. Yeah, I'm very interested in that. I mean, I know there will be problems, but it would be good to have an actual, instance where we see these issues and can measure them. And also, let's work with whoever is interested and see if we can set up some more hands-on kind of event to actually maybe try and write some DDlog code.
So just a quick question. This is ready for scale testing, right? According to your experience.
Right. I think so. Justin, what do you think? Because you know the state of it all.
Sorry, could you repeat the question?
So Han is asking if it's ready for scale testing.
Right.
I don't think that any of the remaining problems are a showstopper for at least running scale tests.
Yeah, I think the scale tests are probably fairly straightforward. I think that would be fine.
Okay.
I think we would get some interesting information. I suspect that we will probably run into issues before we get into kind of core logic errors.
Mm-hmm.
The scenario in the testing scenario in scalability testing is pretty simple, so may not find any functional issues, just about performance and memory consumption and CPU utilization.
Exactly, that's kind of what I was thinking. Is that so? I think it will actually be helpful to run because then the sooner we see those issues, the better.
Okay.
Yeah, that would be very helpful. Sorry about that. All right, so thanks everyone for joining. It was great, and let's keep talking offline.
All right, thanks a lot. That was great.
Thank you. Thank you, Nuni.
Bye-bye.